You're listening to Let's Talk AI.
Welcome to Let's Talk AI. I'm Harold Godwin, Managing Director for Waterloo AI. I'll be your host. Today we have two guests from PolyML. One is Joseph LaFleur, the President, and Marty Witzel, the CEO. Welcome.
Hi, Harold. It's great to be here with you today.
Hi, Harold.
Okay, so great to have you both on board. We're going to start off with probably with you, Joseph, and go back and tell us, how did PolyML start? And then we'll evolve questions from there forward.
Great question. Back in 2018, I was introduced to a technical group who was another firm. They were looking for funding at the time, and at my career path at that point was in capital markets and investment management. Worked for a Bay Street firm, and I'd done some fundraising for companies through most of my career. So in meeting this group, they were fascinating group, very talented, and but they had a little bit of struggles from their previous company, and we got chatting further, and what we ended up doing was founding or starting a AI firm. So that particular company wasn't doing work in AI, and but the goals were to do some work in AI, and we formed PolyML. So really, the key for me moving from Bay Street to PolyML was the people I'm working with today.
Okay, great. And Marty, where do you fit in the picture? How did you get on board with PolyML?
I came in because I'd been working in AI governance. So I have a fair bit of background in innovation and governance and ESG. And I happened to co present with a federal government client with Dr. Gaston Gonnet, who's our chief scientist at PolyML. And the firm invited me to come and speak with them. This is over 2 years ago now. So that led to me taking an advisory role with PolyML, getting to know the team, getting to know the technology. I can't tell you how impressed I was once I understood more about the technology. Now, it took a little while, and sitting with Gaston is a little bit like sitting at the foot of a master because he's renowned. He's one of the original co founders of OpenText back in its original incarnation. And he's a co founder and the author of the software behind MapleSoft, which was originally Waterloo Maple. I'm sure we'll get into a little bit about the technology, but I spent a fair bit of time working as an advisor purely for equity with PolyML. And that has led to my, present very full-time, very 7-day a week, eat, sleep, and pray PolyML. It's interesting. It's International Women's Day today, and I was just on a panel with AI for manufacturing, and one of the questions was, why do you love what you do? And I answered it, but I said, actually, I've just never been more excited about anything.
Well, that's great. You talked about learning the basics of PolyML and what Gaston was talking about. Can you give us a layman's overview of, so what is PolyML? What makes it unique?
Yeah, sure. I'll do my best. Because it's a technical subject, I'll try not to get too technically detailed. And let me place it in the context of the incredible discourse today around AI. It's hard to go online or open up any news source without reading about AI, both the technology as well as the policy and the governance questions. And of course, since November 30th, 2022, there's been a lot of talk about generative AI. So we don't do generative AI. We're a machine learning company, and machine learning is a subset of AI. And there are loads of companies that do machine learning, have been for years, and operators that use it. The banks in Canada, for example, have been using machine learning to develop models for many, many years. For the most part, if you're working with big, complicated data sets, it can really be a struggle. And this is where we come in. We have novel and proprietary technology that allows us to harvest insights from big, complicated data sets. And I will say that our technology is horizontal, meaning that it's not sector specific, it's sector agnostic. We can apply it anywhere where these big, complicated data sets appear. To put a sort of a finer tune on it, If you're trying to predict something or to understand something about the world around you, let's say it's whether this is a case of fraud or not. You're looking at a whole set of transactions and you have many bits and pieces of information you know about every transaction. So maybe you have 100,000 transactions, and think about it like an Excel spreadsheet. You have 100,000 rows. And the bits and pieces of information that you know about every transaction, things like what time of day the transaction was made, who made the transaction, what the value is for, what country it originated in, the last 20 transactions that person made. If you have only 10 or 20 or 50 pieces of information about each transaction, conventional approaches to machine learning do a good job. They can usually go and look at that data set and make sense of which variables about the transaction predict whether it's fraudulent or not. And the reason machine learning is so valuable for doing this is human beings can't sift through the 100,000 rows of data that I talked about. It's just too much. And in fact, it's not usually 100,000 rows, it's usually 8 million rows. So that kind of data set, conventional approaches to machine learning do pretty well at. What they don't do well at is if you have 2,000 or 20,000 or 200,000 variables, bits and pieces of information about the transactions, because most of those variables will be heavily correlated to each other. You end up unearthing big tangles, sort of globs of data, and it's very difficult to tease apart which ones are the predictors. That's our secret sauce. We can go into a data set that has thousands and thousands, even hundreds of thousands of variables, and identify a very tiny number of variables that predict whatever outcome you're looking for. And so, as an example, that could be in a manufacturing plant and to do with a production process.
Okay, so you did mention earlier the term sector agnostic. Which sectors are after this? You talked on, it sounds like fintech there. Why don't you expand further on that?
Yeah. So, I'll say that our company has grown up and been funded through an NGen grant, NGen being one of the 5 Canadian superclusters. And in Canada, when venture capital is more conservative than it is in the United States, um, looking to invest after there's a demonstrated product market fit, these government grants are like an absolute necessity for getting a company off the ground, particularly one with the complicated, involved, high value technology that we've built over the last number of years. So the NGen grant funded us to do a project in the auto parts manufacturing sector, and we were partnered fortuitously with a wonderful partner, um, Martin Rea International, who's one of Canada's big auto parts manufacturers. And this allowed us to apply our sector agnostic technology for particular use cases in the auto parts manufacturing sector, and in particular for robotic welding and for machine press stamping. So I'm sure we'll come back and talk about that. But to answer your question to do with the financial sector and fintech, once I got involved, and because of my background in AI governance, and once I understood more about the technology, and based on our ability to harvest insights directly from data, I realized that in a regulated industry, this has value because it means that the models that we build are always inherently interpretable. This is a really, really big deal because there's a huge cry for trustworthy AI today, being AI that is both accurate and explainable. Explainable meaning you understand how the model is arriving at its outcome. And if your data is simple and you use simple algorithms, like if you remember high school stats using linear regression, it's pretty easy to follow how those methods are taking inputs and translating them into outputs. But those approaches don't work with big, complicated data. The whole world has moved to use neural nets and black box approaches. And the trouble with black box approaches is they might give you highly accurate results, but you really don't have very much of an idea, if anything, about how they're arriving at their outcomes. So that's where we're different, is we can not only handpick these very high value insights directly from the data, but then when we use them to go and build a model, you always know exactly how that model is arriving at its output. And that's the play in financial, it's both. We can bring efficiency, but we bring interpretability.
Marty, I like the analogy we use with the health case and the heart attack. You maybe want to use that as an example of why it's important.
Well, why don't you explain it, Joe? You've got the background there. I mean, Joe, when you and I first met, you talked to me about COVID, which was a bad word. We're kind of starting to forget it, but it's still affecting people. So, what's going on in the health space?
Well, right now we're not necessarily focused in the health space, but we have done a number of projects and reports in science, and our actual technology was created around healthcare. Back in the early days of the pandemic, we were quite interested in why large, sophisticated, strong health system countries had high death rates versus sort of third world countries. So we were interested in what were the outliners of data or of features that why people died or the mortality rate of COVID or from COVID. So our group or our team at the time collected global data, worldwide public data on in various features. So various things such as economics, demographics, trade, education, and we put this in technology, and we wanted to find out what the most important features were. And it was quite interesting on what we came up with. The number one feature, which we would probably expect, was a globalization index. So things such as why people moving from country to country, goods moving from country to country, that's to be expected. But the number two feature, where no one else had come up with, was calcium intake. Countries with high calcium intake had high death rates. It was quite interesting. And we had talked to specialists about it and wanted to make sure that this was correct. And they came back and said, yes, there is a reason for calcium, um, calcium rates and death. There is something important there. So this was quite interesting of what we created, and this is where we are today with what we call our feature importance or our product, which we call FINS AI, Feature Importance Insights.
And you said it's also got applicability in the cancer space.
We did a study on cervical cancer using our technology as well.
Okay, so we've heard about fintech, automotive, health space. That's, let's say where we are now. What does the future look like?
I think the first order of business for us is showing that we can deploy this technology at scale in each of the sectors that we're playing in. So, for an example, in automotive, we have deployed the technology in one Canadian plant, and there is a plan to take this into a second plant in another country, in Mexico. And the technology has been proven in terms of the results it can drive, the efficiencies that it can drive, both qualitative and quantitative. So we see production throughput efficiencies, but we also see part quality improvements because some of the production process issues that we have been able to address that have driven throughput improvements were also causing quality issues. And then we've seen reduced waste and improved plant health. But what hasn't happened yet for our company, because we're still at an early stage, is we haven't deployed the technology at scale across hundreds or thousands of robots. So to show the repeatability and the scalability of the technology is the challenge. I mean, we're confident and we have a partner that we're doing this with, but this is the challenge of any early stage company at a certain point is showing that, you've got an anchor, you've got a value proposition. Now, can you go and do it at scale? And the same will be true for us in financial and eventually the healthcare sector, which are the next two. Um, but it's a different challenge because they're not a physical environment in the same way that a plant is. They're what we think of as sort of inherently digital. And so whereas in a manufacturing sector, there's a services component to our business of we're pulling data off of sensors on welding equipment and stamping equipment. The data gets sent to us, we process it, and the insights that we derive from our secret sauce technology drives adjustments in the production process and improvements. In contrast, in financial, our technology in the form of a product, a SaaS product, will be deployed inside, for example, inside a bank. And banks can't send their data outside typically because of regulatory constraints. So our tools and products will get deployed whether it's on-prem or in the cloud. And the first order of business is to do proof of concept for particular use cases. And again, for a company like us, it's both a blessing and a curse that we have this horizontal technology to mine insights from complicated data. And I would say that use cases like fraud and anti-money laundering, there are numerous different use cases, portfolio valuation, market movements, cash on deposit for banks. There are a number of different sort of prediction and forecast type applications that our technology will be able to be applied to.
Okay, so that's the real tech side of what you're doing. Let's back up a step here and talk about some of these big words you threw out there of explainability, governance, and what organizations or sectors need that, and what is that actually going to look like?
Um, yeah, so AI is really about the policies and practices that companies use to ensure that AI and the AI models are developed, deployed, and monitored in a way that they can be trusted. And so, probably starting back in about 2018, governments and NGOs around the world developed principle based models as a way of starting to think about framing this challenge. And the typical kinds of criteria that they used or the principles were things like transparency, accountability, safety, security, fairness, privacy, robustness. But it's only in the last maybe 2 years that organizations have really leaned into how to operationalize these principles. It's all well and good to say we want our AI to be fair and explainable, but how do you actually do that? How do you develop frameworks that have clearly articulated guardrails with measures and metrics, and then accountable parties that actually do that work? Where PolyML fits into this whole ecosystem of trustworthy AI is we're the ultimate explainable AI model when it comes to structured data and machine learning. And we look at explainability as a sort of a first among equal of all of these principles. And I think that's something that only a few people in the policy literature have spoken about is they sort of tend to lump everything in together. They even say transparency and explainability. Well, they're two different things. Transparency is really an organizational level concept around whether an organization is being transparent and reporting and disclosing on its use of AI. Does it even know where it's using AI? Is the board actually overseeing the use of AI? Do they inventory all their models? I've sat in on sessions educating boards where they learned during the education session from the senior leadership team that they were playing with AI and the board didn't have a clue. So that's transparency. Explainability is, can we make sense of how a model is taking an input and translating that into an output? And the reason that I think, and a few others talk about how explainability is sort of a first among equals, is if you can understand how a model is doing its thing, then you're in a much better position to evaluate all of the other principles that everybody agrees are important to trustworthy AI. So things like the performance of the model, the bias and the fairness, whether it's maintaining privacy rules. So we at PolyML say, hey, if you're working with structured data, our methodology to harvesting insights and building models sets you up really, really well for having trustworthy, high performance AI.
Okay, so you talk about structured. What happens with unstructured data? Do you have a different approach for that, or just can't use PolyML technology?
Yeah, we only deal with structured data. No, structured data to us is both numeric and text, but we don't deal with images, basically. There are lots of companies out there that are applying techniques to images, but that's not our business.
Okay, so I want to go back then to go further now. In the sense of going forward, we talked about different industries, different opportunities. Um, is there a specific problem that's your sweet spot? You talked, I think, about fraud, for instance. Is there one or two that is just like, hey, if someone comes knocking on your door, what's your sweet spot?
Well, I would say right now in manufacturing is our sweet spot that we're focusing most of our time in the manufacturing sector. So with our partner, there are numerous other areas where we can help them on their plant floor. So we're continuing to do work with them on whether it be new equipment, new processes. Um, EV's been talked about. There's an opportunity for an EV project with them. In the banking sector, it's a newer sector we're into, and there's huge opportunities in the banking sector.
It's kind of a two-tiered approach, Harold. I think we're using data analytics um, and harvesting insights from complicated data to solve our clients' business problems. So there's the data analytics problem, and then there's the business problem. We bring in the data analytics secret sauce and help them harvest insights from data that they otherwise couldn't get at those insights today. Or even worse, if they use conventional methods, they might get misleading insights and results. And that does happen. And that's a real concern. And then they take those insights and those models that we construct that otherwise would be inaccessible or misleading. And we together apply them to solve business problems, whether that business problem is in automotive, like welding, as Joe was just talking about, or use cases like fraud in a banking environment, or rare disease research in healthcare and pharma as an example of where I think our technology could be very applicable. And the reason I say that is our sweet spot is really this ability to deal with what's called heavily featured data where you have so many variables about whatever it is you're trying to predict that the conventional methods can't get at it. So rare disease is a typical application of that, because think about it, you might have only a couple of hundred people globally registered as having a particular disease, but you might know 30,000 things about them because you'd have their whole genomic expression, you'd have all their demographic information, you'd know everything they eat and lifestyle choices. And so that data set, going back to my original comment, an Excel spreadsheet would be 30,000 plus columns wide, and you'd only have 400 rows. Uh, I'm just going to say generative AI doesn't play there at all, and conventional machine learning techniques absolutely wither on the vine with that kind of data. But that's exactly our sweet spot.
Harold, to put it in perspective, what our chief technology officer uses this frame with our feature importance with someone else doing feature importance is we do it on super steroids.
Well, that's a great way to put it. So, okay, any final comments then? I think we've got a good idea what you're doing. How do they reach out? How does someone reach out to PolyML?
Well, you can reach out through our website. Anybody can email me directly at marty.witzel@polyml.com, and that's MARDI, like Mardi Gras, MARDI.WITZEL @polyml.com. And we've got a website. I'm active on LinkedIn. Please feel free to LinkedIn with me. And I'm sure the same is true of Joe.
Okay, any final comments from you, Joe?
Thank you very much for the opportunity today. We're living in an exciting time and an exciting industry. So in being in Waterloo and being in actually Canada, there's huge opportunities to broadcast Waterloo, PolyML, and our industry. So we're pretty excited with it, and we look forward to where it takes us from here.
Yeah, Harold, I feel really proud to wake up every day and be part of a company that has novel intellectual property that was conceived of and is being built here in Canada. And probably many of your listeners might be aware of the fact that, and it's frightening statistic, that the OECD has ranked Canada to be dead last amongst the advanced economies going forward for not just the next 10, but the next 40 years in terms of productivity. And I think it will be crucial that we not just invent ideas, but grow and scale the companies and retain our IP inside Canada so that all the economic rents accrue to Canadians over the years. So PolyML is a proud Canadian company with novel IP, and we want to build this big, beautiful Canadian enterprise. It's what I wake up thinking about every day.
Excellent. Well said. Thanks for those final comments. And again, I thank you both for joining us today on Let's Talk AI, and I wish you all the best for the future ahead.